Hello everybody. Let me go through the logics and proof and see how to use Python to implement negation, conjunction, disjunction, exclusive or implication and bicondition. Okay, let us start with the negation. As we already know about the negation, if we have true value, the negation for it will be false, and false, the negation will be true. Okay, let us look to the conjunction, which refers to the AND operand here. As we see, if we have two variables, binary values, here Q, and the variable here was true, false, and then Q, true, false, and B, true, false, then B and Q, true, false, ANDed, so only it will give us true if both conditions or both are true. As we see here, true and true only gives true, and the others will be false. Disjunction, we got in the disjunction inclusive OR, we got true in all cases except only if we have both our conditions as we are false, as we see here. So P and Q, so we have true and true, and then true, false, we got again true. So whenever we have any true, we got true. Else, if all binary values or the condition false, then we got false. Okay, so this is called disjunction. Okay, let me go to exclusive OR. As we see here, exclusive OR, we got true if both binary values are different, but we got false if both are equal or similar. As we see here, P and Q, we got if we have true and true, we got false. If we have false and false, we get false. But if we have true, false, or false, true, we got true, as we see here in this example. Okay. Implications, as we see here in this example, as we see here that if we have P and Q, then again if P then Q, only we got false if B is true and Q is false. As we see here, if B is true and Q is false, only this is the case where we got false result for implication. Okay, so now let us look to this biconditional statement. So if we have if and only if here, okay, so P and Q, we got true if both of them are similar. Okay, so if we have P and Q, true and true, we got true, false and false, we got true. Any other cases, we got false. Okay. So what are the precedence of logical operators? What are the priorities here? As we see here, the negation is the first priority, then AND, then OR, and then implication, and then biconditional. This is very important to execute or any logical operation. Now let us see how to implement negation. As we see here in this script that I already shared with you, that find the negation for B, where B, as we see here, that the binary value, it could be true or false. Okay, so simply we created a function here. We define it as we name it negation, define negation, and then I pass a parameter or the value to it, and it will return the negation for the passed value. Okay, so let me create the set of binary values, true and false, and here is a simple printing just for the variable, and for x in B, so for every x in B, okay, find the negation of x. Let me give it right here. So false, it will be true, and true, it will be false, as we see here. Okay, now let me go to conjunction here. So the AND, so again we define a function called we call it conjunction and we give two parameter, 1 and p, par 1 and par 2, and then it will return par 1 and par 2, as we see here. then we can again create or has as we see here two sets. And since we have two variables here, so the number of elements, it will be 2 to the power n. So 2 to the power n, we have two variables, so 2 to the power n equal to 4. So here we have true, true, false, false, and then true, false, true, false. Okay, so this line is only simple printing, and here for each x in P, for each x in B, okay, and for each y in Q, for each y in Q, I want to display the values and then find the conjunction of the x and y. As we see here, let us give a try. Okay, so here B false, false, true, true, Q false, true, false, true, and then as we see the end of P and Q, it will be false, 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 and true only. It gives a true when both of them are true values. Okay, now let us look to disjunction. Disjunction, here again we define a function called disjunction OR. Then we have parameter 1 and parameter 2. So simply we return the OR for part 1 and part 2. Okay, so let us run this one, and again we have two variables here, P and Q. Then we want, again we use a loop iteration for every element in P and for every element in Q. Then we want to display x and y as an element for P and Q, and then display or the returned value from this junction function. Okay, as we see here, it gives only false whenever P and Q are false, and else give true. Whenever we have any true, we got true. Okay, so now let me implement this one. If we want to find the negation, if we want to find not between brackets B or Q, so in this case we want to find B or Q first, because parenthesis has high precedence or priority than negation, then negation. Okay, so here simply we can find the disjunction or for x and y, and then find the negation of the result of this disjunction. So simply here I displayed B and Q, and then once we got the negation of or x or y, as we see here, or P or Q for every element. So here B or Q, false or false, it should give us false, and then the negation of false here, it will be true. Then false or true, it will give us true, and the negation will be false, and so on. Let me give a try for this one, as we see here. Okay, now exclusive OR. Exclusive OR, as we see before, that if x and y are equal, then we get false, else we get true. So here exclusive OR, we define again function exclusive OR part 1 and part 2, bar 1 and bar 2. If bar 1 and equal 2, then return false, else return true. Okay, so simple like this, as we see here. Let me print this one. Okay, true, true, false, false, true, false, true, false is in simple printing, and again simple iteration for each element in every set. Then simple again display and give a tab, this /t give this tab here in between. Okay, and then exclusive OR of x and y, so it will take each and every element. If they are equal, it return false. If it's if they are not equal, it return true. So here false, false, return false, true, true, return false, and any other combination, it return true. Okay, implication. Implication, it will return only false if the first condition or binary value is true and the second one is false. So let us look to this example here. Define the implication of bar 1 and bar 2. If now we define the method or the function that we will use it. Okay, so if bar 1 equal true and bar 2 equal false, then it will return false, else it will return true. Okay, let me run this one. As we see here, again two binary variables P and Q, as we see here, and we implement the implication, call the implication function. So false, false, true, all true except only if it's true and false, we got what? False. Okay. Okay. Now biconditional, and only if. In if and only if both are equal, then it will return true. If both are not equal, it will return false. So define a biconditional bar 1 and bar 2. If bar 1 equal bar 2, then return true, else return false. Simple like this. Okay, so now here again we declare two sets, and then we displayed using tabs. So here we can display the values and leave tabs here in between, and then we display the x or the values here true, true, okay, false, 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 true, and true, false, and true, true. Okay. Then biconditional of x and y, we call this method that we already declared, and here is the result we got. It seems that I did not run this one. Let me try it again. Okay, so you have to execute this first method. Okay. Okay, tautology. Tautology is the cases where we have the output all true in all cases. Okay, and as we see here, we want to find B or Q or not B or Q. Okay, so we want to find B or Q between brackets, and then or not B or Q. Okay, as we see here, we have to find what is in between brackets first. So we have to find B or Q, then we have to find B or Q again here, then we have to find negation, and then we have to find the OR operator here. Okay, so this will be the last one. Okay, so here if you look here for this one, where is this first conjunction? This first disjunction, sorry, this is the first disjunction. Okay, where is the second disjunction? This is the second disjunction. Okay, then where is the negation of the second disjunction? This is the negation of the second disjunction, and then we want to find this OR. Okay, so here the join or disjunction OR for the whole terms or the result that we have just received. Okay. So the same method that we already declared before, disjunction and negations. There is no change here. Okay. As we see here, that we got true in all cases. This is called tautology. Okay. Contradiction in the opposite or contradict for tautology. We got false in all cases, as we see here. So if we want to find instead of or that we used before, we can find and. Okay. So here P or Q, then not P or Q, and then find the and for both of them. So here again disjunction of P or Q, and then negation of P or Q, disjunction B or X or Y here as an element for B and Q. Then conjunction, which is the and here, so I want to find the conjunction and for these terms. So here false and false equal false, true, false, false. So false in all cases. This is called contradiction. This is the end of this lecture. I hope that you enjoyed it. It's very easy and simple. You need just to try to write and define these functions by yourself, and try to execute it using Node Jupyter here. Also, you can clone it and enjoy your time. Thank you.